Hello everyone. In this video, we are going to learn moving charges and magnetism. All the important questions for second PUC, CBSE 12th, KCET NEET. All the important formulas we are going to cover. First one, magnetic force due to a moving charge. Whenever charge is moving, charge Q is moving, okay, in the magnetic field B is the magnetic field with velocity V, so it will experience a force. What is the force? QVV sin theta. Okay, or we can write Q into V cross B. Next, Lorentz force. Whenever the charge is moving in both electric field as well as magnetic field, so it will experience a electrostatic force as well as magnetic force. Electrostatic force is what? QE, and magnetic force is what? QVB sin theta. If you take a Q outside, so we will get a Q whole into E plus V cross B. Okay. Next, magnetic force due to a current carrying conductor. Okay, if a current carrying conductor, okay, I is current in the conductor of length L, it is placed in the magnetic field B. So it will experience a force. Force is equal to BIL sin theta, or we can write F is equal to I into L cross B. Next, radius of circular motion of a charge moving perpendicular to the uniform magnetic field. Whenever Q charge is moving in the magnetic field B, okay, and it at an angle 90 degree, means it is entering perpendicular. So what is the radius of the circular path? Radius is equal to mv by qb. Next, angular frequency. W is equal to qb by m. Frequency f is equal to qb by 2 pi m. Time period t is equal to what? 2 pi m by qb. Okay, Biot-Savart law. Okay, whenever current carrying conductor is there, okay, of elementary section dl at a point p, distance r, okay, it will experience a magnetic field is produced. Okay, magnetic field dB is equal to mu naught by 4 pi idl sin theta by r square. In vector form, we are writing dB vector is equal to mu naught by 4 pi I whole into dl cross r by r cube. Next, magnetic field on the axis of a circular loop. Very important. Okay, so dB is equal to mu naught by 4 pi 2 pi n I r square by x square plus r square to the power 3 by 2. Here n is the number of turns, I is the current in the circular loop. Okay, r is the radius of the circular loop. Okay, r is the radius of the circular loop. Okay, and x is the point. X is the distance from the center. Okay, where we have to find the magnetic field. This is a circular loop carrying current having n number of turns is there. Okay, so this is the expression. If you in the same, if you see at the center, magnetic field at the center of the circular loop, mu naught by 4 pi twice of pi n I by r. If number of turns is suppose 1, so how we are going to get a b is equal to, okay, n is 1, so 2 pi get so here it is mu naught by 4 pi is what? Mu naught by 4 pi. Okay, so due to a circular coil having n number of turns, radius is what? R. So mu naught by 2, okay, I by R will get. Okay, next, Ampere circuit law, B dot dl is equal to mu naught times of I. Okay, next, magnetic field due to a current carrying conductor. Current carrying conductor produces a magnetic field, okay, at point P, which is a distance of R. Okay, so B is equal to what? Mu naught by 4 pi twice of I by R. If you cancel this, you'll get mu naught by 2 pi I by R. So from here we can see that B is inversely proportional to the distance. If distance is more, magnetic field strength is what? Less. Inverse relation graph like this. Next, magnetic field due to a solenoid, mu naught times of Ni. Solenoid is what? A circular coil having n number of turns. Yes or no? And n is the number of turns in the coil, I is the current in the coil. Solenoid actually. Next, force between two straight parallel conductors. Let's two parallel conductors are there carrying current I1, I2, and distance between them is what? D. Okay, so it will experience a force. Force is equal to mu naught by 4 pi twice of I1, I2 by D. If the current direction is in the same, so it will experience a attractive force. If a direction of current is opposite, it will experience a repulsive force. That you have to keep it in mind. Next, torque acting on a rectangular circular loop placed in the uniform magnetic field. Tau is equal to what? Mb sin theta, or NBI A sin theta. What is magnetic dipole moment? M is equal to what? I into A. Okay. You want to convert galvanometer into ammeter, then you have to connect a very small resistance called a shunt resistance in parallel. Okay, so the value of shunt resistor is what? S is equal to Ig into G upon I minus Ig, where Ig is what? Current in the galvanometer, Capital G is what? Resistance of the galvanometer. I is the current which we have to pass minus Ig. Galvanometer to voltmeter. If you want to change a galvanometer into voltmeter, so we have to use a very high value resistors in series. Okay, so this is the R resistors. So it will change. It will become what? A galvanometer change into voltmeter. Okay, so here what will happen? R, if you want what is value of R is equal to V upon Ig minus capital G. So these are the all important formulas of this chapter. I hope you understood. Please practice once, like the videos, share with your friends, and don't forget to subscribe the channel. Thank you.